This is the second part of lesson 10, and this is the experiment part. So I have a fair number of instructions, so I'm still going to go through a little bit of it and point out a few things. One thing I noticed is that in the list of equipment, I just said DMM for the orange meter. You also need the other orange meter so you can measure the inductance and the capacitance of those. So what you're going to need is the resistor, the brown, black, brown, and then you need a capacitor. You have two capacitors. The one that you're going to use is the bigger one, and it says 224K. And then you have a little coil. This is the inductor. So you can sort of find those. So the first thing is to measure the resistance, and it should be about 100 ohms. And then the capacitor, to read those, well, it explains there, so I think you can read. It turns out to be about 0.22 microfarads, and the inductors, generally the coils, there's nothing written on them, so in order to figure out what they are, you have to use the meter. A couple of things about the meter, though, that I do want to point out. Let's get this over here. I'll see if I can get it where it does not glare.
Up a little bit.
Up a little bit. Is that better?
Oh, it actually was good before.
Better before?
Yeah.
Actually, let me stand it up.
Now we're good.
Is that better?
Yeah.
Okay. So of course the power button is over here. And then for the inductor and the capacitor, there are two little holes here that you can put the ends into, but in order to do that you have to bend the wires so much. I think it's better to just use the these little short leads that come with that. So you have one in the minus and one in the plus over here. Then the other important thing is to measure inductance, which is L. Notice that little white thing tab is sticking up, so the blue button is up higher. If you want the capacitor, you push it in and then it sort of stays in. You push it again and it comes back up. So I'm going to push it in for capacitance. Capacitance is in farads, which is down here, and I'm not going to show you that, you can just do it. And then the inductor is in this region that says L here, so it tells you what dial to set it on. You would need to have this one out, and then you can measure those and record those. So that's what you need that for. Okay, then you're going to use the oscilloscope set at 7,000 hertz, so 7 kilohertz. The idea is that for an RLC circuit, it should work for anything, any combination. But if you're going to have the vectors long enough that you can see them relative to each other, you have to have certain values. And so I have gone through, picked out a capacitor, inductor, and a resistor so that the vectors are a nice length and they're fairly easy to deal with when you go to draw the phasor diagram for them. So to set it at 7,000 hertz, it needs to be set at the 10K position, and then the variable knob needs to be set about 2/3 of the way clockwise. And in here it explains two things. It explains the long way of getting that 7,000, and that's what you actually did in lesson 8. The other shorter way is to use the DMM, and I'm not going to do this, but I'll just put this up here to show you. You need to have the red and the black in the usual holes, and then here in the lower right hand region there's a 2K and a 20K. Since we're going to measure 7,000, that's 7K, you'll need to set it on the 20K, and then it will just display the frequency, and you can adjust the frequency dial so that you get 7,000. Now, I would suspect it's hard to get 7,000 exactly, but as long as you're within a few hertz of that, then that's okay. Okay, now we're going to set up the circuit. So we're going to do very similar to what we did before. I took the other one apart, but we'll put it back together. We start with the ground wire connected to this outside, so we put it in a row that goes to that. We just put it over here in some region on the circuit board. And instead of putting the red wire next, I'm going to add the other things and then we'll put the red wire last. So we're going to start with the resistor in the same row as the ground wire. So we'll put it in there. Remember, it's the 100 ohm, which is brown, black, brown. And then we'll put the other end just up there somewhere. And I'm going to put the capacitor next. And technically it doesn't matter what order you have them in, but since we're going to be measuring certain things, there are certain ways to measure these things. So we're going to start with the resistor first, then we're going to put the capacitor. Be sure it's in the same row as that end of the resistor, and we'll put it up there. And all three of these, the resistor, capacitor, and inductor, it does not matter which end you put in which place. The inductor goes next. Now the inductor wire is a little bit, the leads on it are a little bit bigger than the others, so it's a little harder to get into the hole. So be kind of gentle, careful, firm, whatever, to get it in there. And then we'll put it up here somewhere a little bit higher. So we have the resistor, the capacitor, the inductor, and make sure that they are in the proper rows or you won't get anything, which is what I did a time or two. Okay, now we need to connect, finish the connection, so we're going to connect from the inductor, put the red wire in the same row as that, and then bring it back to one of these holes here that go to the frequency generator. So we have our circuit complete, and then let's see, we need to start measuring something. Okay, you're now ready to make measurements. So what we need to do is the black alligator clip is the ground, the probe ground, and I'm always going to call it that. Now we can connect it down here as we did before. I think I'm going to connect it up here on the lower side of the resistor because it's a little more obvious what we're measuring across. So we're going to connect the we're going to connect the hook to the resistor side, and somewhere before this, if you follow the instructions, it will tell you about amplitude, how much amplitude. Notice several things. This looks like just a green band. So we need to change our time, and it tells you in there what time you need to use, or you'll be able to figure it out. You need to have it something like this, and then I'm going to turn the amplitude up just a little bit. You can also change this to the 0.5 volts per division. So something to get a nice looking wave there. Let's see, if we turn this, we don't want the waves that close together. Oh, wrong direction. We could have them that far apart. Actually, in this, it's probably better if they're a little bit closer together. Now, we're going to fill out the table on page 88. So I'm going to tell you and kind of show you what to do. I'm not going to actually get the numerical values for you. So the Vmax from the oscilloscope is from the horizontal axis to the maximum. It's the amplitude. And then the meter, we're going to use, make sure we use the right one. We're going to use our meter to measure voltage, and this is an RMS voltage, as we had learned in the previous lab. So I actually still have it set here on 2. We could do that, or we could, it's set on 20. We could do that, or we could do 2. Let's see what we have here. Voltage. Okay, I have 0.5. It should be a little more than that if you get it set right, as it says to begin with. So we could turn this, if we wanted one more decimal place, we could turn it to the 2. And I think, though, that some of these voltages are going to be more than 2, so I'm going to turn it back to the 20. Okay, so we would measure that, and that goes in the row that says meter. Okay, I'm going to take this off of here. Oh, and sometimes when you're taking meters off, things come apart. So I'll turn the meter off, put my circuit back together. Okay. Then we want to measure, at some point we want to measure all of these things across the function generator. So since it's at the end of the row, we'll wait till the end to do that. Now, the important thing is, once you measure those, and then the RMS value is just 0.707 times the oscilloscope value. So that will get you the resistor values. Now you want to measure across the capacitor. And here's a very, very important feature. If we want across the capacitor, what we would normally do, and I almost hesitate to even say this because I'm afraid someone will actually do this. What we would normally do is just take our ground wire and our probe hook and move it up there to the capacitor. But you absolutely cannot do that, because that will put the ground at 2 different places. Okay, let me just take this off of here. Okay, now I still got the resistor in there. You cannot have the ground in more than one place, because the ground of the oscilloscope, which is the alligator clip here, and the ground of the circuit board have to be the same place. If you have them different places, you're going to damage something or cause some sparks or smoke or something. I'm not sure. That's one thing I have not tried to see what actually happens, so just don't. So then the problem is that we need to be able to measure across the capacitor. So what I'm going to do is call this position next to the ground wire the measuring position. So what we're going to do is take the resistor out, move the capacitor to that position, and then I'm going to put the resistor back where the capacitor was, making sure I've got things in the same row. And again, remember, this is series, so it does not matter which order the things are connected in as far as our measurements. So now then we can connect to the capacitor, the ground clip, and our hook to the other side of the capacitor, and we can see what kind of measurement we have. So it looks about the same, and as it turns out from the values that I've used, that's about right. You should measure exactly. When you're measuring, you need to make sure that the vertical position, that it's adjusted so it's exactly in the middle. It's exactly as much above the horizontal axis as below. So you would go through, make the measurements for the capacitor, and then we need to make the measurement for the inductor. So again, we have to move things. So we take the clips off of the capacitor, take the capacitor out, move the inductor down there, so it is there. So our inductor is here next to the ground wire. And then we can put our capacitor up here where the inductor was. So again, as I said, it does not matter which order they're in, but the position next to the ground wire is what I'm going to call the measuring position. So whatever you're measuring the voltage across, it must be in that position. So now we're going to connect our probe ground to the bottom side and our hook to the other side. Now we notice this is a lot taller, and that's what I found for mine, so that would be good. So we cannot see the tops and the bottoms, so we need to change the scale on this. And it might be a good idea, those boxes are large enough that you could actually write how many centimeters times what scale, so that if you were looking at it later, you would know exactly what data you were getting. Okay, so you would make all the measurements for the inductor. Then the last column is the function generator. So what you can do, leave the ground there, and then just connect up here to the top, so that we have from here to here. Now if you want to, you can take this one out and connect. Actually, that's probably what you should do. Because if you want the function generator and you really don't want the other things affecting anything, so now I need to move this back the other direction. Okay. So you can make the measurements there. Let's see. Actually, I'm not sure that that's quite right. Hold on a second. Okay, you should have those three in there, and then you do want to have this connected so that you can measure with these in there. And we'll go back to here. The reason is because our voltage across the inductor, capacitor, and resistor are going to add to, well, with the vector addition, they should add to the voltage of the generator. So we do need to have the red wire in there so that we're actually measuring across all three for the function generator. Okay, so that should help you get the measurements. And then on page 89 it says to measure the current. So you need to have the orange meter again, but you need to move the red lead over to the milliamp hole. When you were using the yellow meter to measure current in unit 1, you didn't have to move the lead, but that meter will measure current only that's DC. It does not measure AC current. This one will measure AC current, so that's why we have to use this one, which means that you have to move this or you will likely burn out a fuse. And then you need to make sure that you have the dial set properly. Oh, where's A? Okay, down here at the bottom we have an A with a wiggly line, so we'll need to turn this down to probably the 200 milliamps. When I did mine, I got about 6 milliamps, so it's probably more than 2 milliamps. And then you have to open the circuit just like you did before. Oh, actually, let's see here what we can do. Oh, well, we could leave this attached. Actually, I'm going to take it off. Got too many things on there. So if we're going to measure current, then we need to break the circuit. I'm going to break it up here at the top end because the inductor wire is hard to get in and out of there. So it doesn't really matter which side I put to which. So I'm going to put the red one to this red one and the black one over here. And we get about 3.6 milliamps. Now, if you remember, I said I don't have this adjusted to what you're supposed to have and what it tells you in the lab, but you can see that we still are getting a current there. So you would do that, and then, as always, you need to take the meter out and restore your circuit. And then I'm going to turn this off and move it. And then that's the last of the measurements. So the rest of this is some calculations using your values. The last comment that I have, let's see, I think we're done with this. I want to write something on the board. So while I'm coming around the table and Adrian's readjusting the camera, you should go through the calculations, make sure you keep track of milli and kilo and all of that. And then on page 91 in the phasor diagram, the phasor diagram that you had drawn before was in terms of voltages. But if you remember, voltage is current times resistance. So actually you drew them in terms of voltages sometimes and in terms of resistance and reactance. However, one thing you did do was to draw, or what I did was I drew them not along any particular axis. And to make this simpler, it works better if you will put the resistor voltage on the x-axis. So we have the resistor voltage here, VR, and remember that the inductor voltage goes up. So we'll go up here, this is VL, and the capacitor voltage goes down, so it would go down here, so VC. And then if we're going to add those, we can move this one up to here, so this will come back down to like here. So this region here is VL minus VC, and this is the one that I said you should draw it to scale. You might use 1 volt equals 1 centimeter. That's what I did, and it works out very nicely. So if you do this, then you can have the vector addition here, like this, and then the hypotenuse here is V max, and the angle here is the phase angle. So when you draw that to scale, and it should look something like this, not exactly, but sort of, you should end up with your Vmax being about what voltage maximum you had doing the experiment, and your phase angle here, if you measure it with a protractor, it should come out very close to your calculated phase angle that's just at the top of that page. Okay, so on this, hopefully everything will work well for you. If you have problems or questions, feel free to call me or email me, and we'll see what we can figure out.